Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey Houston, let's talk about maybe one of the most confusing things in all of kinematics, the study of motion, and that is the acceleration time graphs. These can be quite confusing. Let me just say this one thing at the top. They tend to be blocky. You'll see what I mean by that. So let's draw some different graphs and talk about what they mean. So let's take this motion. So this is distance versus time. We'll do the AT one in just a little bit. So what happens is somebody starts at the point 0, right? And they start getting faster and faster and faster till they get to this point, right? And then they stop. So they go faster and faster and faster, and then they stop from here to here, right? And then they start walking at a constant velocity until they get to this distance, whatever it is. Then they stop. Then they turn around and walk back at a constant velocity, and then they stop. And then they start walking faster and faster and faster at back towards the original place, and then go backwards, and then eventually stop. So what would a velocity time graph look like from this graph, right? So in this case, they are increasing their speed, right, at a, if you will, a constant rate. We'll assume this is a constant one. So what's going to happen is the velocity is going to go up to here, right? So it's a constant speed, right? So the slope of that line. So the slope of this line is a straight line, right? And at this point they're stopped. So the velocity would then drop down to 0, right? That's what that means, right? And then it's going to increase to another speed, right? So now they're increasing. It's really the slope of this line will be a flat line for the velocity, right? So like it's 6 or some number, who knows? And then it's going to drop down and go down flat again for this next segment, all right? And now we're going to go at a negative velocity. So the negative velocity is going to be like this. That's this right here is this line right here. And then we're going to stop. And then what's going to happen is now we're going to have a increasing or decreasing, pardon me, acceleration, and it's going to look like this. So that's the VT graph. And what's the AT graph? Now that's where the issue, the AT tends to be blocky. All right, so this part right here, the slope of this line is a number, right? It's a straight line. So the beginning acceleration is going to be something like this. And then the acceleration, the slope of this line, right, is 0. See the blocks, how they're coming out? And then right here, this is the one that's kind of confusing, I think. The slope of this line, even though they're moving at a constant velocity, they're not accelerating. So it's still going to be flat at 0, right? And then when they're stopped, they're accelerating at 0. And when they're here, they're accelerating at 0. And here they're accelerating at 0 from here to here. But at this point, we're now going to have a negative value, and that's your acceleration graph. So the acceleration time graphs can be kind of confusing. Let's just do one more. So let's say we have this one, another complete graph. So this is a velocity versus time graph. What would the corresponding AT graph going to look like? So for this part, they're increasing at a constant velocity. So you're getting faster and faster and faster. So you are accelerating, right? So you're accelerating. So what's going to happen is this is going to be a straight line for this segment from here to here. From here to here, if you will, the slope of this line is a straight line. So it's going to be up and positive. So slope of whatever the slope of this line is, okay? And at this point, though, it's be flat, flat. It's stopped. So the slope of this line is 0. And so this is going to drop down to 0 for this portion right here. That's from here to here. And then from here to here, the slope of that line is negative. So we would drop down here, and it's relatively steep. So maybe it's all the way down here. And it would continue from here to here. That goes to here. And then back here, of course, we're going to be 0. Notice how that looks very blocky. Sometimes you can have sort of the triangular thing. But AT graphs, or acceleration time graphs, can be confusing. Right? This is the AT graph. And this is the VT graph. If you just think about the slopes, it makes sense. Just what's the slope of this? It would be a constant, all right? Or it's going to be increasing, right? So that's the slope of this, and then this, right? That's like, you know, if this slope here is like 3, right, rise over run, then this mark is 3, and if this slope is like 10, negative 10, right, then this would be like negative 10 right here, whatever this, you know, the rise and the run right there. So hopefully that helps you understanding acceleration time graphs, because Houston, it can be confusing, but you guys, you're awesome. You get it. You're smart. We'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.